In the classification of hydroelectric plants, we have seen the nature of the load, the head of the plants, and we have seen the quantity of water flow. So according to the head of the plants, we described the low, medium and the high head plants. On the same way, in the same way, we can also define the type of turbines which we are normally using for different type of hydroelectric plants. So, in the types of turbine, we have two types of turbines normally working in hydroelectric plants. One is called the reaction turbine and another is called the impulse turbine. The basic difference between these two turbines, the reaction turbine and thus impulse turbine, is that the reaction turbine, the water is coming and some of the head is converted into the kinetic energy and rest is as a pressure head. So the very much important thing in reaction turbine is only some part of the head is converted into kinetic energy. So some part of head is converted into plus the remaining left is as the pressure head. So, what is reaction turbine? So, reaction turbine is what? That in which some part of the head is converted into kinetic energy and the remaining part is in the pressure head only. So, the thing which is important is kinetic energy plus the pressure head is in the reaction turbine. Whereas in the impulse type of turbine, all the available head is getting converted into the kinetic energy. So all the head which is available is getting converted into the kinetic energy is called the impulse type of turbine. So there are two types of turbine, one is reaction turbine, another is the impulse turbine. So in the reaction type we have three different types, all the types. One is called the Francis type, another is called as the one is called the Francis type of turbine, another is called the propeller type of turbine, third is the Kaplan type of turbine. All these are under reaction of type of turbine where some part of the head is getting converted into kinetic energy, remains part is in the pressure head only. Transverse propeller. Transverse propeller and the propellant type of turbine, all three are in under reaction type of turbine. Whereas in the impulse type of turbine, Pelton wheel is coming. These are the four names which are normally used in hydroelectric plants. One is called the Francis turbine, another is called the propeller turbine, and the third is called the Kaplan turbine, fourth is called the Pelton wheel. All three, Francis, propeller and Kaplan, FPK, all are in the reaction turbine, whereas the Pelton wheel is under impulse turbine. So what is the use of what type of turbine? We'll see that. So the Francis turbine is normally used for the head of 70 to 500 meters. Up to 70 meters, my propeller turbine will be used, and the Kaplan turbine will be used below 30 degrees or up to 30. Whereas the Pelton wheel is used above 500 meters of height for the head. So one can classify according to the head that when it's a low head plant, we'll be using Kaplan turbine. It's a medium head up to 70 meters, we'll be using propeller type of turbine, and above that we'll be using the Francis turbine up to 500 meters, and above 500 meters we'll be using the Pelton wheel. So the speed also depends. So higher the head, lower will be the speed. So, but obvious, lower will be the head, higher will be the speed. So the Kaplan turbines are normally working at a very high speed of 300 to 1000 RPM. Whereas my propeller turbine is also among the same, is 300 to 1000 RPM. Means both two are almost on the same speed. Whereas Francis turbine works on 80 to 400 RPM. Coming to Pelton wheel, the speed is very low. It is 12 to 70 RPM. So one can define now all type of turbine with the speed also, with the height also, the type also. So if there may be questions regarding all the four turbines, which is the highest speed turbine, so we can say the Kaplan is the highest speed turbine. The lowest speed turbine is the Pelton wheel. One can classify these according to the height also. So 30 meter up to 30 meters Kaplan turbine is used, and for above 500 meter Pelton wheel is used. So we can keep them in increasing order of either in the speed, either in the height also. So in the increasing order of the height, we can use Kaplan, then propeller, then Francis, and then the Pelton wheel, increasing order of the height in which they are used. In the decreasing order, we can also say that the Pelton wheel, then the Francis wheel, then the propeller, then the Kaplan will come. So this type of question may be asked in the examination. So please remember this way, the way which is given in this. So another part which it may be possible that this is not visible to you right now. Now it is visible that it is up to 300 meters to 1000 meters they are used. sorry, 300 to 1000 RPM they are using, 80 to 40. So one can also classify the according to the speed, increasing order of the speed of the rotation of the turbine. Is the Pelton wheel is the lowest speed, then the Francis, then the propeller, then the Kaplan type of turbine. So one can also accordingly classify the according to the speed also. So this is a very important thing, because this thing is normally asked in the theory type of questions, that which type of turbine is what doing what. So please remember this thing. Apart from this, another thing is that Pelton wheel, since the speed is slow, so it is always always below the lowest tail race, as well as the in these type of turbine are always placed above the minimum tail race. See that turbines, how the turbine are moving. So apart from that, we have hydro generators, which are actually generating the electricity, and which actually are the heart of the your power system generation plant. So in the hydro plants, hydro generators are there, and which are normally classified as low speed, silent pole, large number of poles. Since it's a silent pole, so the diameter will be large. And fifth will be the small axial length. Everything is correlated to each other in the hydroelectric plants. So one can say that since it's working on the low speed, since they are low speed, so but obviously the number of poles will be higher, because we know the F is equals to Pn by 120, or the number of speed is inversely proportional to the number of poles. So the more number of poles will be there, lesser will be the speed. So since one, and you can say in the different way also, that since there are large number of poles in hydro generator, so the speed is low, and since the speed is low, so we'll be using the silent pole of rotor, and the silent pole, because of silent pole, the rotor diameter will be larger, and since it will be larger, diameter will be larger, the height of the machine will be high, but it will be compact in nature, and the small axial length will be of the hydro generator. So one can remember this thing, but have to remember these things, that the hydro generator are normally of the low speed, very low speed. They have silent pole of rotor. There are large number of poles in it, large rotor diameter, and a small axial length. All things are important regarding theory objective type of questions.